Training AI usually requires just massive amounts of data, and every single piece has to be painstakingly labeled by a human. But what if the AI could just teach itself without any of those labels? Well, today we're unlocking one of the most powerful concepts driving modern AI, self-supervised learning.
So what is it, really? Put simply, self-supervised learning is this really clever method that AI models use to basically teach themselves. They learn from these huge, vast amounts of raw, unlabeled data. And believe me, this ability to learn without human-provided labels is a complete game changer for building powerful, large-scale AI.
Okay, so to get our bearings, let's see where this fits in the big picture. As you can see here, self-supervised learning is a specific type of unsupervised learning, and that whole family sits within the massive field of machine learning, which of course is a cornerstone of artificial intelligence. So think of it as a very clever, super specialized tool in the ML toolbox. And this right here, this holds the secret sauce. So the crucial question is, right? Without human-made labels, how does the model even know what to aim for? Well, it creates its own goals. It generates its own training targets directly from the raw data it's given. It's kind of like a student creating their own practice quizzes straight from a textbook. Now, what's really fascinating is how that process actually works. It's this elegant little loop. First, the model takes a piece of data and just hides or masks a part of it. Second, it tries its best to predict that missing part. Third, it checks how close its prediction was to the real thing and updates itself to get better. And fourth, you guessed it, it just repeats this cycle millions, sometimes billions of times, getting smarter with every single loop. That might sound a little abstract, so let's make it more concrete. How does this really powerful idea apply to something we all use every single day, like language? Okay, let's see this in action. Imagine the model gets the sentence, "the quick brown fox." Its task, the goal it has set for itself, is to predict the next word. In this case, the actual next word, jumps, becomes the correct answer, the label it's aiming for. So the model guesses, checks its answer, and learns from its mistakes, reinforcing the right connections. This simple prediction game is really the core mechanic. Now, let's scale that simple prediction task way, way up. Instead of just one sentence, what if you give the model nearly the entire internet? Every book, every article, every website. With this method, the internet itself literally becomes the teacher. The model learns all the nuances of grammar, context, and even reasoning just by constantly playing that predict the next word game. This is the big breakthrough that enables these massive foundation models we hear so much about. We're really just scratching the surface of how AI learns. If you're finding this stuff useful for understanding these core concepts, make sure to follow us so you don't miss the next piece of the puzzle. In our next explainer, we're going to tackle a completely different way machines learn, reinforcement learning. This is where an AI learns not from static data, but by taking actions out in an environment and learning from the rewards or the penalties it gets back. It all really comes down to this one fundamental question. How does a machine learn from pure trial and error? A lot like we do. We'll explore that next time. Stay curious,